Hello everyone, welcome to a new lecture. In this video we are going to talk about soil. Soil has been called the bridge between life and the inanimate world. All life, or in other words the entire biosphere, owes its existence to a dozen or so elements that must ultimately come from the Earth's crust. Once weathering that turns big rocks into sedimentary happens, it creates soil, and plants carry out the intermediary role of bringing together the necessary elements and making them available to humans and other animals. So let's ask, what is soil? Well, soil is layers that is produced by weathering, and it's a combination of mineral, organic matter, water, and air. Soil is referred to as an interface or a common boundary where different parts of a system or different parts of our system comes together. So soil is an interface where the biosphere, the geosphere, the hydrosphere, and atmosphere comes together. One recognizable fact about soil is it can support the growth of plants. Without this property, none of us, no human beings, no animals would be able to live on Earth. So soil is extremely important for life generally on Earth. So let's look at a couple of the usefulness of soil. First, as we mentioned, soil is a medium for plant growth. Beside that, soil can store water, and it can supply and purify, and finally it can modify the Earth's atmosphere. So due to exchanges between the atmosphere and soil, soil can modify the Earth's atmosphere. So how many types of soil do we have? Well, we have three basic types of soil. The first one is clay soil, the second one is sandy soil, and the third one is silt soil. Clay soil particles are very small and compact. Gardens with these types of soil particles don't work well because the air has a hard time getting to the roots. The soil absorbs and holds water and creates a drainage problem. This adversely affects healthy roots and plant growth. So clay soil acts as a trap, and they don't work well with plants, since interaction between this type of soil, air, and water is not very good in supporting the growth of a plant. On the other hand, sandy soil particles are large. The water and nutrients, particularly nitrogen, quickly drain away from the plant's root zone. Sandy soil is the opposite of clay soil. Clay soil is sticky. They stick together and there isn't a lot of room between the particles. But sandy soil, on the other hand, they have big particles and there are a lot of room between one particle and the other. This allows water and nutrients to drain away from the plant's root zone very, very quickly. The last type of soil that we have is silt soil. Silt soil is made up of fine particles like clay. The soil holds water but does not have a good aeration around the roots. So these are the three basic types of soil that we have. But chances are that you haven't thought a lot about the soil under your feet. You may be surprised at the complexity of it. If you look down at the soil under your feet, you cannot tell very much about it. But if you dig a meter or two, the soil will not look the same. So as we go deeper, there are changes in the composition, texture, structure, and color of the soil. And this is called the soil profile. So what is soil profile? Well, the soil profile is horizontal layers of soil that vary in composition, texture, structure, and color as you move downward. So the soil that you see on the surface is not the same as the one that you would see if you dig a meter or two. If you dig a meter or two, you will see variation in composition, texture, structure, and color, and based on that, soil has been profiled, has been turned into horizons. So this is basically a profile picture of soil, and it is composed of the top layer, which is called the O horizon, and then after that comes the A horizon, and then the E horizon, and then the B horizon, C horizon, and finally we get unweathered parent material. These are the horizons that you see if you dig a meter or two of soil. So let's look at each of these horizons in more detail. The first one is O horizon, that stands for organic matter. The O horizon, or this layer, generally forms above the mineral soil or occurs in an organic soil profile. As we mentioned, the O stands for organic matter. This horizon has partially decayed organic material. The lower portion of the O horizon is made up of partially decomposed organic matter humus, in which plant structures can no longer be identified. Also, there is microscopic life, including bacteria, fungi, algae, and insects. So this is what the O horizon is. The other horizon that comes after the O horizon is the A horizon. The A horizon is a horizon that contains mineral matter mixed with some humus, with high biological activity. Together, the A and O horizon make the topsoil. The A horizon is the topmost mineral horizon. This layer generally contains enough partially decomposed homified organic matter to give the soil a color that is darker than that of the lower horizons. The next horizon is the E horizon, and the E horizon is short for elevation. So this horizon is zone of elevation, which means washing out of fine soil components, and leaching, which is depletion of soluble material from the upper soil. This horizon contains little organic matter. The next horizon is the B horizon, which is subsoil. It has a lot of fine clay material, and it's the layer where most of the material removed from the E horizon by elevation is deposited. The B horizon, the E horizon, the A horizon, and the O horizon, all these horizons or all these layers together is called a solium, or the true soil. This is where most of the living plants, roots, and other organisms reside. So in the O, A, E, and B, in these horizons, which is called the true soil, in this area, roots and other organisms reside. The other horizon that we have is the C horizon. The C horizon has partially altered parent material. Since after the C horizon, we have unweathered parent material, some of the weathered parent materials come to the C horizon, and as you can see, some of the bedrock is weathered away and is in the C horizon. So the C horizon has partially altered parent material. The last layer of soil that we have is called the unweathered parent material. This layer has unweathered hard rocks. So this is just the bedrock that hasn't been weathered away. So now you know the layers that compose a soil profile. So let's see an actual soil profile in real life. This is a soil profile. If you have soil and you dig it for a meter or two, this is what you see. As you can see, the top one is the O horizon. After that comes the A horizon. After that, the E horizon and the B horizon, and finally we get the C horizon, and after that we get the unweathered parent material. As you can see, the C horizons contains some of the unweathered parent material, and beside that, the picture does not show it, but there is unweathered parent material or just bedrock. The B horizons or the subsoil has a lot of fine clay material. It is the layer where most of the material removed from the E horizon by elevation is deposited. Above that, we have the E horizon, which is the zone of elevation, washing out of fine soil components, and leaching, which is depletion of soluble materials from the upper soil. This horizon contains little organic matter. So as you can see in this horizon, the E1, it contains very little organic matter, and it's the zone of elevation and leaching. Above that, we have the A horizon, which is the horizon that contains mineral matter mixed with some humus. And on top of all that, we have the O horizon, which is the horizon that has partially decayed organic material. This partially decayed organic material. This horizon, the lower portion of the O horizon, is made of partially decomposed organic matter that is called humus, in which plant structures can no longer be identified. And as you can know, the O horizon and the O stands for organic. As you can see, this is soil profile, and with this we come to the end of our lecture. So to recap the entire lecture,